The trends in the periodic table, for the most part, can be determined just by looking up the different values they're looking for in Table S. For some of them, it might be easier to memorize. Metallic character, reactivity, these are things that can't be looked up directly in Table S. So they may be something that's attached to other characteristics like first ionization energy or electronegativity, or just knowing that metals are on this part of the periodic table and nonmetals are here. And that may help you in order to understand those particular trends. For a lot of them, though, it's just a matter of looking it up. So if you are asked what is the trend in ionization energy as you go across the periodic table, you could remember that first ionization energy actually measures the amount of energy required to remove an electron. Knowing that the metals are on this side of the table and they tend to lose electrons easier, and nonmetals are on this side of the table and they tend to want to gain, so they wouldn't have low ionization energies, you would know that going across a period, the ionization energies increase. But why would you remember all that when you can just look up the ionization energies in the periodic table? So taking the second period and starting with lithium, the ionization energy of lithium is 520, and then it goes up to 900. 801 kind of dipped down a little bit, but then carbon is over 1,000. Nitrogen is 1400, and so on. So the general trend is that the ionization energy increases as you go across a period. When you look it up for a group, you may want to pick a group that's easier for you to keep flipping back and forth because the numbers are not sequential. It's going to be a little more difficult to look these things up. So beryllium is atomic number 4. It's 900. Magnesium, the next one in group 2, is atomic number 12, and it's 738. It appears to be decreasing, but you never want to decide on a trend when it's just two elements. So let's look up calcium, atomic number 20, and it is 590. So it's definitely decreasing. So as you go down a group, ionization energy is decreasing. You can do the same thing for electronegativity as well. Going across a period, it actually increases. What you will find is that electronegativities are not given for the noble gases, and that's because electronegativity measures how badly they want to gain an electron. If a noble gas were to do anything, they would lose an electron, they wouldn't gain, because they do have that stable valence shell or a stable octet when we talk about neon down through to radon. Helium, keep in mind, is stable with only 2 valence electrons since the first principal energy level can only hold 2. So looking at some of our elements, fluorine is the most reactive nonmetal, and that's because fluorine is relatively small, which you can look up in the atomic radius, and also it has 7 valence electrons. So its electronegativity would be really high because it's going to really want that last electron. And its nucleus is fairly exposed and relatively close to the shell that it would be gaining that last electron in, so it could use that strong attractive force of the protons in the nucleus to draw that last electron in. So this one is going to be our most reactive nonmetal. And actually, by trends, we would expect our most reactive metal to be francium, but when you actually look at ionization energies, it ends up being cesium. But the point is the same. The lower the ionization energy, the easier it is to lose an electron. And as a result, since metals want to lose, the lower the ionization energy, the more reactive that metal is. So in this lower corner is where you're going to find our most reactive metals.